what we're going to do here is continue with this. Like I've said, I took one section of this and I broke it down into 4 different parts. So we are going relatively slowly with it. But this is, the whole idea of this is to give you an introduction to what you will likely see next year. Again, it'll probably be about week 5, or like 5, 6, 7. I mean, it'll be, or I'm sorry, not week 5, 6, 7, but it'll be about 5 chapters, maybe 6 chapters into the class next year. So it'll probably be like right around the either end of first semester, start of second semester, and that you guys will be doing these. And again, your teacher might do something slightly different than me, and so this gives you a chance to see it in multiple ways, hopefully. Okay. All right. So the first thing is just a quick review of what we covered in the last one, and that is to be able to sketch a graph without any changes in the amplitude, the highest point and the lowest point, in the distance from the midline for that. Okay, by seeing if you can sketch this graph. So I want you to see if you can sketch where sine of 4x would be based on what we talked about in 8.1a. So just really quickly see if you can plot that on the points here. The couple things to keep in mind on this, and it should be something that you can answer relatively quickly, okay, is that the sine and cosine both have a calculation for the period of 2 pi divided by whatever the b value is. The b value is that coefficient, the multiplier in front of x inside the function. So in this case, that's a 4. And now, normally you probably would look to simplify it in this form. So we have our period is pi over 2. And now, this tells you that each of these grid marks on the horizontal grid marks here represents pi over 16. Okay? And so what this means is our graph is going to complete one cycle of, again, since it's a sine, the order of your 5 critical points in the sine graph go midline maximum, midline minimum, midline. And so that full cycle right there is going to occur during an interval of pi over 2 radians. Right? So that's what the period means for that. Now, if it tells you that this is pi over 16, well, what is pi over 2 in terms of 16ths, if we think of it in the incremental grid marks here? 8 over 16, right? So what this means is that every 8 of these grid marks, your cycle is going to complete. So if I was sketching this, what I would do is I would see, here's my starting one, right? Because again, the sine starts at the midline, and then it goes maximum, midline, minimum, midline. Okay, so those are my 5 critical points on the graph for a sine. Okay, so if I am marking pi over 2, that means that every 8 of these units, so 1, 2, 3, 4, 5, 6, 7, 8. So this graph is going to repeat during this span of time. So if I cut this in half, okay, that means that every 4, it's going to be halfway, and if I cut each of those halves in half, what I can see right now is I can see where my critical points are going to fall. So if I was sketching this by hand, not on the computer yet, but if I was sketching this by hand, what I would see is my first point is a midline, my next point maximum, midline, minimum, midline. Now my max and min values are 1 and -1 because we haven't started talking about that yet. That's what we'll talk about today. And it is a 1, all right? That's the multiplier in front of your sine or cosine. And so this right here would actually be the sketch of one period of my graph. Okay, now, because we're using this system here, what we need to do is choose the graphing utility that relates to or represents sine, which is this second one. The one that on your graph, you choose the midline followed by the maximum. Okay? And so what we can do is we can plot any of our midline points, or first select this graphing utility button, plot any of our midline points, and then move to the next, which is the maximum. So if I select those 2 points, the graph is going to fill in all the rest of what I'm looking for. Okay, so everything else will be filled in just by plotting those 2 points in blue. right? And so that's what you would do for this graph. Okay, now, the way that you can think about, or again, like that's how you want to think about it if you need to sketch it out somewhere differently to find those critical points and then plot them on there. But if you think in terms of 8 pi over 16 and then count 8 units over, cut that in half, then cut the half in half, so cut it into quarters, you'll find all your critical points. All right, I want you to try this second one here on your own, doing the same idea, but this time with the cosine of 6x. And can you sketch what that graph would look like based on the same process, except now you're going to use the cosine graph instead of the sine. All right, so if we do the same idea, find the period by taking 2 pi divided by whatever the multiplier is in front of our x inside that function, which is a 6. Okay, and once again, normally you would find the period by simplifying that. We get pi over 3. But because we're being told that these, each of these horizontal grid markings represent pi over 24, what we're going to do, and you can do it directly from this first part if you want, but I'm going to simplify it to show what you would likely do next year. And I put it into the pi over 3, but pi over 3 is going to be how many 24ths? 8 pi over 24, right? So what that means is there's going to be 8 between 0 and then 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be from 0. Oops, let me write that below here. So from 0 to this marking here, which is hard to see, right, with how kind of squished together the labels are, which is why it says that each of them represents pi over 24. But that is your one period. So that's the amount of, that's the interval over which it takes for the cycle of cosine to complete one time. Okay, so what we're going to do is we'll look at the cosine starts at a maximum, then goes to midline, then minimum, midline, then back to maximum. So those are the 5 critical points on a sine graph. So what we would do is our first point, we're going to start at the maximum, which is 1. Or actually, let's cut this in half and quarters. So if we look halfway between the 0 and 8 pi over 24, we get 4 pi over 24, cut each of those in half as well. So here's our 3, here's our 3 critical points. And so if we label, we start at a maximum, a midline, a minimum, a midline, and a maximum. Okay, so that right there is one period of the graph for this equation. Okay. Now, when we're plotting this, we use the cosine function right here. And notice that the way that the cosine function has their points to designate the graph is it has one minimum and one maximum, right? You can think of them in either form, but a minimum and then a maximum. So what you would have to do is you would select this point, and it would self-populate the rest of the graph for you. Okay? So those are the 2 points that you would use if you were using the cosine button, the cosine graphing utility button. Okay? Now, what if you took this first graph right here on the left, and let's say you chose the cosine button. If you chose the cosine button and you plotted maximum and minimum, it would fill in this exact same graph and you'd get the points for that. Okay? The sine and cosine graphs are the same, they're only shifted differently, horizontally shifted differently. Okay? If you'd have hit this sine button here and you clicked on the midline, and then it can be either max or min, either of these, whatever the next one is. If you clicked on these two, it would also create this exact same graph for you. Okay, so it doesn't matter which one you choose. I do recommend that you get the feel of both of them. Okay, but again, your max to min is the cosine function. Your midline to maximum is your sine function as far as the graphing utility is concerned. Okay, but you can do either one. Questions on that? And this will be answered probably a little bit more when you actually start to do the homework for it. All right, so we talked about the period of a sine and cosine function in the previous section. This one we're going to focus mostly on the amplitude. Okay, and so the amplitude is the sort of relative height of the maximum and the minimum from the midline. Okay, it's the distance the maximum is, or the extrema, the maximum and the minimum are from that midline, the point on which the graph oscillates or the wave repeats. Okay, so when you're looking at the amplitude is simply going to be the absolute value of your multiplier in front. Okay, whether that multiplier is a positive or a negative, it affects a reflection of the graph, and so it does determine something about the graph's appearance. Okay, but when you're finding amplitude, the sign doesn't have any consideration for that, so you just need to take the absolute value of A. Okay, so what would be the absolute value, or I'm sorry, what would be the amplitude of this first function? 8. And what would be the amplitude of this second function? 1/9. Okay? So the amplitude, finding the amplitude should be very, very basic. Okay? Now, the midline, let's talk about that next. Oops, I'll use a different color. Okay, when you're finding the midline is just the vertical shift. Okay, and it's going to be an equation, okay, of this. The midline is going to be at this equation, y equals whatever your vertical shift is, and the vertical shift is d. So what would be the midline for this first problem? So y equals -8. Make sure you write it as an equation. And for the second one, it would be y equals -9. So again, finding the midline also should be really straightforward type of process. Right, the max and min then are just a sort of a combination of these. The maximum is going to be the midline plus your amplitude, and the minimum is going to be the midline minus that amplitude. Okay, so if you want to find your maximum point, what you're going to do is you take your midline plus 8. What does the -8 plus 8 give you? 0. Okay, and then the minimum is going to be -8 minus the amplitude. So -8 minus 8 is -16. Okay. So the midline's always going to be halfway between the min and the max. Okay? And so you can find it with those calculations. So just really quickly, see if you can complete the remaining two, the max and min of this second problem. What are those values going to be? And you can use calculations. That's part of why I wrote it in green up here. You can simply write these. So here you could take your midline, -9 plus 1/9, and that should give you a preview of your decimal value. However, -9 is how many ninths? So if you looked at it in the fraction form, -81 plus 1/9 leaves you with -80/9, and then the same thing here, -9 minus 1/9, and that's going to give you a total of -82/9. Okay, so that's finding your amplitude for both the sine and the cosine. Okay, it's exactly the same for each one. Okay, which means here I'm going to copy this into the next slide. I want you to see if you can answer both of these questions here based on that given cosine and sine. And our amplitude is 8. Again, remember it's not a sign included with it, right? It's always a magnitude. It's an absolute value. Okay, and the amplitude of the second problem is 8/5. Again, it's always a positive. Okay, the midline's the next easiest thing to find. The midline is just your vertical shift, so y equals, in the first one, 3, and in the second one, y equals 1. So there's your midlines. And then you can take your max and min just by calculating the midline plus the amplitude, the midline minus the amplitude, and that's going to give you your max and min. So 11 for the maximum, -5 for the min. And we're in the fraction form. Again, if I take 1 plus 8/5, 1 minus 8/5, 1 is 5/5. Okay, so you can think of them in these either the fraction form, or you can just type a calculation in. But here we get 13/5 for a maximum, and the minimum -3/5 for your calculated values. All right, questions on that, finding those additional pieces of information regarding your graphs? All right, so this is the calculation way to find it. You might also find it visually. All right, and so a midline is halfway between these two the max and the min. Okay, so if you want to find the amplitude of this, what you're going to do is you take your max and your min. Okay, you're going to take the difference of those values, right? We want that total distance. So here we're taking our total distance of 10 minus a -2. Okay, and the distance is calculated as an absolute value. So that's going to give us a minus is a plus. So that's an absolute value of 12, which is 12. And the midline is going to be halfway between that. Okay? Or sorry, the amplitude is going to be half that length. So our amplitude is going to be 6 for this. Okay? So if you went 6 units down from 10, or you went 6 units up, so this distance of 6, or you went 6 units down or up from -2, those should meet at the exact same point, and that point is your midline. Okay, so the way that you would calculate this is your amplitude is 1/2 the distance between your max and min. Okay, so this is your amplitude. If you wanted to find your the midline is going to be the average of those. So if you add those together and divide by 2, that gives you your midline. Okay? Now, the midline is easier to find by just taking your vertical shift and adding or subtracting the amplitude, but those are sort of the two calculations involved in this. Okay? All right, so again, I want you just to find the midline here, or I'm sorry, find the amplitude in this second problem. Okay, so we have a maximum at 4, a minimum at -2. So we take the difference of these in absolute values. Subtracting a negative is like adding its opposite, so we get 1/2 of the absolute value of 6, and that is 3. So our amplitude is 3. If we count it down, 1, 2, 3, 1, 2, 3, we can see that halfway between these is your midline, but the amplitude is this distance. The distance from the midline to the max and the midline to the min. And once again, your midline would be that horizontal line. Okay, so the amplitude's 3, the midline would be y equals 1. All right, and when you are sketching the graph of these, and again, we're not putting it all together quite yet, we're just focusing on the amplitude. The amplitude change happens with the max and min points. And so if you're being asked to sketch the graph of 2 sine of x, and so notice in here now the period's not changing, so the period is still 2 pi divided by just our, as it would be in the parent function, a 1. Okay, so that means that your critical points, okay, it repeats during one period of 2 pi, so it goes from 0 to 2 pi. Okay, and again, we cut that in half and cut each of those halves in half, so here are our 5 critical points. With a sine goes from midline to maximum to midline to minimum, back to midline. And now our amplitude, though, is this number 2. So the amplitude is equal to absolute value of 2. So here's our max, and here's our min. And so here, when we plot our graph, we start with the midline, then a maximum, midline, minimum, maximum. And so here is one period of our graph. But the points that you need to select, you choose the sine function. The sine function is midline and then maximum. So those are the 2 points that you would select to create this graph, and it'll auto-populate the rest of the graph for you. Now, once again, if we chose to use this graph, if we use the cosine function or the cosine graphing utility instead, what we would choose is we would pick a maximum point and a minimum point. So you could also complete this graph by choosing the cosine button and then selecting those 2 points, the maximum and the minimum, and it would still create that same graph for you. All right, so try the next graph on your own. See if you can sketch the graph of 8 cosine x based on just the amplitude change and what we've discussed already. Okay, so our period is 2 pi divided by the coefficient of our x inside the function, which is 1. So we know our critical point here goes from 0 to 2 pi. So there's 1 period. So if we cut those off, we go halfway between and then halve each of those halves, so a quarter of those. And so there's our 5 critical points. Okay, and when we look at our amplitude, the amplitude is absolute value of 8. So we're going to go 8 units up. So here's our max. We're going to go 8 units down. There's our min. Okay, and since we are dealing with a cosine, the cosine graph starts at a maximum to midline to minimum to midline back to maximum. So there's one complete cycle of this graph. And so when we plot this, since there's no horizontal shifting, we'll plot our maximum, or first we select the correct tool. Okay, so our cosine tool, we go from maximum to minimum. Well, remember, we go maximum, midline, minimum, midline, maximum. So this would be our sketch. Okay, and when you're selecting the points for this, we would choose our maximum and our minimum. So those would be the 2 points that you would select with your graphing utility in order to fill out the rest of this graph. All right. So let's take a look here at the next sort of combination of taking a given graph and finding both the amplitude and period of that graph based on what we see in these general tendencies and rules with how the functions are set up. All right. So here's the main thing with these graphs, and this is what your graphs tend to look like. Do these graphs look like their wave functions? No, and you can even see like that they dip down a little bit like these here and here. Okay, there's some inconsistencies in what these graphs look like when they get squished together, where there's a lot of them sort of combined in a small horizontal part. When this happens, do you notice a dot on that graph? So you notice this dot here, or on this one, this dot here. If you see a dot on the minimum or the maximum, that means it's likely from a cosine function. It's a point on the cosine graph. If you see a dot in the middle, it's likely on the midline, and that's coming from a sine function, probably. And again, both of these can be expressed both in either way, right, as either a cosine or a sine. But that gives you a general hint about what kind of a graph it came from. And your assumption is going to be that the lines that are the closest to these that you see right here, those are your max and min values. Okay, so you do have to make that assumption, okay, for this, because the graphs are slightly inconsistent in the trig ratios for some of these. Okay? So what that means is when I'm finding the amplitude, that's probably going to be the easier of the two things to find, right? So the amplitude for this first graph here is going to be 1/2 the absolute value, the difference of the max and the min. Well, my maximum is at where? 1. My minimum's at -3. So if I take 1 minus a -3, minus a minus becomes a plus. I get 1/2 times the absolute value of 4. So that gives me an overall amplitude of what? Now, does that make sense? Could I draw a midline halfway between the max and min? The amplitude is the distance between those. So I'm going to write it over here. But so that would be my amplitude. It makes sense. That is, if you count it and solve it visually, that's 2. Okay, same here. All right, the period is the one that's a little bit tougher, and you have 2 ways that you can calculate or identify the period. Okay, so one of the ways that we identify the period is to figure out how many cycles are there within 2 pi. Okay, if you find out how many cycles there are within 2 pi, then the period is equal to pi over that number, right? So that is your value B. How many cycles? That's your B number. Okay, and so the period is just going to be, the 2 pi over that number. Okay, so the period is 2 pi over B, or the absolute value of B. So if you count how many cycles there are and find that B value, you can identify the period. The other way that you can calculate or find the period is to see what's the interval that it takes to repeat one cycle. And so depending on what you see, you have to choose one of these 2. Okay, so if you were to look at this graph right here, so you see that it has a minimum right here, okay, and you can see one cycle ends right here. Can you tell what that value is with certainty? You have an idea, right? It looks like it's about halfway between like 2 given values, but you don't know it exactly. Okay, and so you can't be certain on this. But what you can be certain of is if you go from here to here, what's this total distance right here based on my graph? It's 2 pi, right? Can I count how many of these cycles complete within 2 pi? So I can count, here's 1, 2, 3, 4, 5, 6, 7, 8. And so I have 8 cycles that completed during that 2 pi. So my period is going to be 2 pi divided by 8. And what does that simplify to? Pi over 4. And so that would be my answer for this. Okay, so I found my amplitude easily. And then I counted how many cycles can I complete during a span of 2 pi. And I calculate that using 2 pi divided by b, the calculation for period, and that gives me my answer. All right, I want you to see if you can kind of extend that rule on the next problem and find both the amplitude of period there, please. So the point that I give you for these is what you might want to use, and then just find a distance of 2 pi away from that given point, and then count how many cycles occur during that interval in order to find your period. So the amplitude here is the easier of the two, right? It's 1/2 the absolute value of the difference of your maximum, 9, minus your minimum, -1. Minus minus is a plus. So 1/2 of 10 is 5. So if you go 5 units up, and again, you see it right here, we could have just counted from here to here as well. Right? From the midline of 4 all the way up to 9 is a total of 5. So there's your amplitude. That part was easy. Okay, calculating the period's going to be a little bit tougher. Okay, so if I start at the point where I was given, okay, so the point I was given was right here, -5 pi over 4. If I move to the right a total of 2 pi units, okay, how many more pi over 4s do I need to go past 0 to get a total of 2 pi? 2 pi is how many pi over 4? 2 pi is equivalent to 8 pi over 4, right? So I have 5 to the left, so how many do I need to move to the right? A total of 3 pi over 4. So right here, I see is the total distance of 2 pi. Or there's my interval, 2 pi. So what I want to do is I want to count how many of these sine functions, or sine function cycles, occurred during this. Now, sine is a little bit different, right? So the cosine goes from max to max, or min to min. The sine passes through a minimum to the midline, maximum back to the midline. So what you see right here is that it's not every one time it passes through this midline, it's every second time, right? So here I have 1, 2, 3, 4, 5, 6, 7. Okay, so it took 7 cycles. Okay, 7 cycles during the span of 2 pi. So when I find my period is going to be 2 pi over 7. And so that's my answer. Doesn't simplify any. But I found it was 7 cycles during the span of 2 pi. And that's what the period represents. All right, did everybody see how I counted those visually? Yeah, Alex.
So the first graph, if you counted from that dot, it'd only be 2, but on the second graph, you counted from the dot.
Okay, so let's come back and take a look at that. So if you're going from the dot on this first one, right here, the dot is at 3 pi over 2, right? So as we come this way, 3 pi over 2, we need to go how many pi over 2 more to get to a total of 2 pi? Well, so 2 pi is 4 pi over 2, right? We have 3 pi over 2 that way, so we need 1 more, right? So this is going to go all the way here to between 3 pi over 2 and then the negative pi over 2, right? That is the span of 2 pi. Okay, and so if we were to do that down here, here is your point. And so now we're looking to see how many are there. 1, 2, 3, 4, 5, 6, 7, 8. So we see there's 8 cycles during the 2 pi. So 2 pi over 8 gives you pi over 4, which is your answer. So I went from the 0, because like if you can see the 0, that's great. In this one, the second one, you can't see where the 0, right? The 0 is of some fractional unit. And so going from the given dot, the given point, is going to be the easier way to do it. All right. So the final question is just the calculation of all of these, okay, for both sines and cosines. Okay, and I'm going to do, and we're going to introduce the negatives a little bit here. Okay, but I'm going to do the first column for both of them, and then I'm going to have you try the last two. Okay, so for the first one here, okay, the amplitude is going to be absolute value of -2, right? The number out front, so that gives you 2. The period can be found by taking 2 pi divided by the multiplier in front of x, which is 1. So 2 pi is our period. And then the phase shift. The phase shift is the value when you look at your sine or cosine. So if I go a times the sine of b times x minus, and I think I use c's and d's on this. Okay, so this right here is your phase shift. What value of x gives you a 0 in here? Well, when I look inside, what value of x gives me a 0 inside this function? 1/4 pi, right? Pi over 4. So pi over 4, it's shifted to the right, pi over 4. So it's just like every other horizontal shift. You take the number inside your function, set it equal to 0, solve for x, okay, and that's your answer. Okay. I'm going to jump down and do this one here because and then I'll have you try the remaining two. Okay, when I'm solving for this, the same idea, right? The amplitude is the absolute value of the leading coefficient, or the number multiplier in front, so 4. The period, I'm going to take 2 pi divided by, what is the coefficient in front of x? 5, so 2 pi over 5 doesn't simplify any. There's my period. Now, before I actually do that, or you can do it at the same time, but what you're going to want to think about is you want to remove the common factor of whatever's in front of your x so that you get this form right here. So that b value is a 5, and if I take out a 5, I'm left with an x plus. And when I take out a 5 from 5/6 pi, I'm left with 1/6 pi, right? So that would be what my graph looks like if I factored this. And then all I need to do now is use the inside. So what value of x gives me a 0 inside here? A negative pi over 6. And so that would be my phase shift, or my horizontal shift for that graph. If you took your original function, if you took this 5x plus 5/6 pi, set that equal to 0 and solved, you're still going to get this same answer, right? If you, right, 5x is equal to negative 5/6 pi, multiply by 1/5, and the 5's cancel, you get negative pi over 6. So you get the same answer if you take the whole thing, but it's going to be easier when we get into sketching the graphs to just remove that as a common factor. That is your b value. Okay, so that's your b. Okay, and then the phase shift is easier to see as well. All right, so try these two problems here really quickly on your own. So I'm going to do the lower one first because that's a slightly simpler one. Amplitude is my multiplier out front, 2. The period, there is no multiplier in front of x, so it's just 2 pi divided by 1, which is 2 pi. And I can see my vertical, or my horizontal shift inside. What value of x gives you a 0 inside? Negative pi over 9, or negative 1/9 pi. You can write it either way. Okay, up at the top, amplitude, multiplier in front, 4. The period, now here we take 2 pi, divide by, what's the multiplier in front of x? 4, that reduces, so pi over 2 is the period. And then the phase shift, again, if we had taken this as 4 times the sine of, take out that common factor of 4, I'm left with x minus 1/5 pi. So there is my horizontal shift of pi over 5. So it's shifting to the right. Pi over 5 would be your phase shift.